scientist of America. Today I have a guest here, my son, Everett. Everett, say hi.
Hi.
So Everett's going to take us through this lesson today. He knows a little bit about Isaac Newton, so we'll see how much he really knows today on our lesson. We're going to talk about Newton's first law of motion. All right, so today let's think about motion and how this guy here, the picture of Isaac Newton, if you look at him, and what he did for science and motion. Remember, our essential question is, what is motion? And this guy here, this long-haired, robe-wearing, prism-carrying, scientist, natural philosopher guy, came up with the first law of motion. And today we're going to read from this book here, everything you need to ace science in one big fat notebook. It's a great book. In fact, it's Everett's book. I stole it from you, didn't I?
Yeah.
Yeah. Well, we borrowed it today.
Yeah.
Borrowed it. Okay. All right. So let's read from this book here about Newton's laws, and then we'll answer a few questions at the end on Google Classroom. I'll post the questions. You can watch over this video again. And like anything, if you like this book, it's got everything in it, doesn't it, Ev?
Yes, it does.
Yes, a lot. Everything.
Yeah, a lot.
Yeah, a lot. Okay. Here we go. Chapter 10. Can we skip to the 10th chapter? Can we do that? Yeah?
Yeah.
Why not?
Why not?
Why not?
Why
Okay,
not?
skip right to the 10th chapter. Here we go. Force and Newton's laws of motion. Force. What makes something move? What makes a car speed up? What makes the wheels on a bike turn? The answer is force. A force is a push or pull, and force is required to change the motion of an object. The force you exert on the pedals of a bike makes the wheels turn. In a car, the force behind motion is an engine.
Force always has magnitude, size, and direction. Forces can set an object in motion or change the speed and direction of motion. Movement doesn't have to be moving from one location to another. It can also be changing the shape of something. Think about squeezing an empty soda can until it crumbles. You haven't thrown the can in the recycling bin, but you have caused motion by changing its shape.
Have you ever squeezed in a soda can?
Yeah, I have.
Just crushed it.
Yeah, just
crushed it.
Just crushed it.
Okay.
Just like, just crushed.
Just crushed it. Okay.
Yeah.
Net force. This must have something to do with catching butterflies or fish in a net. Is that what this is?
Yeah.
Okay. All right. Maybe.
Maybe.
I'll read this one.
Okay. Yeah.
Looks like there's a magnet up here.
Yeah, sure.
Okay. Sometimes there is more than one force working on an object. For example, when you pull a magnet off the fridge, there are two forces at work: the magnetic force holding the magnet to the fridge and the force you exert on the magnet. The combination of all the forces acting on an object is called the net force. The net force on an object can be calculated by adding all of the forces on an object together. For example, the little pink rectangle, one force pulling to the left, another force pulling to the right. Add them together, you get net force.
Force is like velocity and acceleration. Has direction.
Very good.
Yeah, I might have read that wrong, but
That's
okay.
all right. That's all right.
So, to calculate the net force, you need to take direction into account. If the forces are in the same direction, you add them. If the forces are in opposite directions, you subtract them.
Okay, Isaac Newton figured out force, so the unit that measures it is named after him. The SI unit for force is a Newton, abbreviated with a capital N. 1 Newton is the force needed to accelerate an object with a mass of 1 kilogram at 1 meter per second squared. In other words, here's the math problem in the yellow box. Side note, in fact, to hold up an apple against the force of gravity requires about 1 Newton of force. I'm surprised he can hold that apple up there with those legs and arms like that.
Yeah, exactly. He's pretty skinny.
Needs to hit the gym or something, huh?
Yeah, for sure. I mean, I don't know, how, his boots are that big if his legs are so tiny.
I agree, yeah. How does he even move the boots?
Exactly. Yeah.
Okay, well, we'll see. All right. force and motion. So here we go, the connection between the two ideas. You want to read?
Sure.
Okay.
Isaac Newton figured out all of this force and motion stuff, and he came up with the laws of motion to describe the motion of all objects in the universe.
Newton's first law of motion is, an object in motion will remain in motion, and an object at rest will remain at rest, unless there is a net force acting on the object.
Wow. That's nice.
Sorry.
Okay.
I get a little into this stuff.
Yeah.
Yeah, okay.
Yeah.
For example, a soccer ball is lying in an open field. It will remain sitting there unless an outside force acts on the object, like someone kicking the ball. Once the ball is in motion, it will remain in motion unless an outside force acts on it, like friction between the ball and the grass, air resistance, gravity, or another soccer ball stopping the ball with another soccer player, stopping the ball with his foot. On the other hand, if you kick a ball in deep space, it would keep going until gravity from a star or planet bent its path. Why would you kick a ball in deep space? It'd never come back.
Exactly. You'd have to, and plus, you'd have to go up in space.
Right.
If you kick it from here, it'll just go like,
What?
10 feet up
Man.
in the air and then just fall.
Would you go to space and kick a soccer ball out there?
No, I'd
No?
go to space to do flips and stuff, but
Flips? Yeah.
not just to kick a
Not
soccer
just
ball.
to kick it, yeah.
That'd
Okay.
just be dumb.
Yeah. Yeah. It'd be fun though.
It would.
Okay. How about this word? What is that? Inertia.
Inertia.
Oh, inertia. Okay.
Come on. You know this.
Inertia and momentum.
Matter doesn't like to change what it's doing. If it is in motion, it likes to stay in motion. And if it is at rest, it likes to remain at rest. Inertia is matter's resistance to change in motion. Matter will remain at rest or in constant motion unless acted on by an outside force. That's why Newton's first law is sometimes referred to as the law of inertia.
The law of inertia.
That sounds kind of cool.
That does sound kind of cool.
It's got a nice ring to it.
It does have a nice ring to it.
Yeah.
It's a good band name. Law of inertia.
Law of inertia.
Law of inertia. Okay. Last page. Ooh, last page.
Oh, dang.
Okay. Objects with more mass have more inertia. Think about catching a tennis ball as compared to catching a basketball. If they have the same velocity, it is easier to stop the motion of a tennis ball because the tennis ball has less mass than the basketball.
Yeah.
Makes sense.
Yeah.
Momentum is a measure of how difficult it is to change the inertia of an object. You can calculate it with the formula. And there's more math for you, right?
Yeah.
Momentum equals mass times velocity. All right, Ev, last paragraph.
Okay. Conservation of momentum. If energy isn't lost during a collision, maybe through friction or heat, the amount of momentum in a group of objects before and after a collision is the same. For example, when you play pool, the momentum of the cue ball is transferred to the ball it hits, and the amount of momentum in the system remains constant, except for the little bit of energy transferred to heat when they collide. The law of conservation of momentum can be used to predict the velocity of objects of any mass and velocity before and after they collide.
Very good.
That
Nice
was a
work.
lot of big words.
That was a lot. That sounded fancy.
It did sound
That did,
fancy.
yeah. Law of conservation of momentum. Well, we did it.
Yeah,
We finished. You think we should look at the questions we need to answer?
maybe.
Okay.
Yeah, we should.
Okay, think. Could we answer these questions here? Number one, what is a force? Do you think you can answer that one? Don't answer it. You don't want to give the answer away.
I know.
Could you?
Yeah, maybe.
Okay. How about this one? Two, you and your brother are playing tug of war. You pull with a force of 15 N. Do you remember what that N means? Newtons. Good. And your brother pulls with a force of 10 newtons. What is the net force? And then finally, I think we should probably know this.
Yeah.
What is Newton's first law of motion?
Yeah, we should probably know that.
Okay. Is that fair?
Yeah, that's fair.
Okay. Hey, thanks, Ev, for reading today. Everett was joining us today, and we did a little reading on Newton's first law of motion and force. So answer that question in Google Classroom, and we'll see you next time.
Bye. Yeah.
Bye-bye.